archived, and we will be placing this up on a blog here on Laser Technology site in about a week, and we'll send everybody out a little notice when that's available. To just get started, just to tell you guys a little bit about Laser Technology. I won't bore anybody, but we have been in business for over 30 years. So, Eric, if you can advance that slide.
You got it.
And we actually got our first really cool project we did for NASA. We built a custom laser for these guys for some space docking missions in the early 90s. We were actually also responsible for the very first recreational rangefinder. We partnered up with Bushnell Optics, again, in the early 90s, and we're still developing their rangefinding technology today for golfing and hunting. Up in the upper right, you see this contraption. This is actually the very first GPS laser offset equipment. It certainly had a lot of weight to it back in the day, and that was, again, about mid-90s. And then to the far right at the bottom, we certainly have taken our technology down to really the size of a recreational rangefinder, but it certainly has all the professional measurement capabilities that you could ever want. So with that said, I'm actually just going to go ahead and turn it right over to our guest speakers today and have them introduce themselves.
Hey, great. Thanks, Paul. So this is Eric Gackstetter. I'm going to be moderating today. So my background is I started in GNSS and actually with lasers back in the 90s. In fact, I remember seeing the Criterion down at a show in Reno then when it was just first being introduced with Bill Carr from the Forest Service started driving it. But yeah, I sure have come a long way. So anyway, I started in sort of space in 1990 as a product developer for 10 years. If you remember the old MC GPS or March receivers from CMT, those were our babies back then. Did that for 10 years. In 2000, I quit and formed my own consulting company and wrote for GPS World for a lot of years, for more than 10 years, all on high precision kind of subjects. And then did a lot of outdoor mapping, mapped a lot of golf courses. It's interesting that Paul mentioned the golf lasers, but yeah, I mapped a lot of golf courses, used the lasers to map trees along golf courses. And then more recently, in the last, 6-7 years, I've been really involved in helping other folks with product development with GNSS technologies and software development, too. So, yeah, great to be here, and love to sort of talk about the different field experience and technology itself. And so I'll let Mike Colodi introduce himself.
Thanks, Eric. This is Mike Colodi. I'm a GIS project manager with Mazer Consulting. I've been doing GIS and GPS field data collection for about 15 years now, using different various equipment over the years. I started my career working doing GIS and data management for environmental investigation and remediation. And about 4 years ago, I came over to Mazer Consulting, and we're doing GIS projects and GPS data collection for all different types of clients here in the Northeast and along the East Coast. So using GPS, GNSS to capture features for different municipalities and utility authorities. One of the big things here in New Jersey that's been a big focus this past year is Water Quality Accountability Act, which is requiring, the state's requiring all of the utilities to GPS locate all of their valves and hydrants. So there's been a lot of action here in the Northeast with that. And I guess next up is Mike George.
Yes, thanks, Mike. Yeah, my name is Mike George. I'm a project manager here at DDSI. We are a design, drafting, and survey company. We primarily work in the oil and gas, telecom, local government, and residential and construction survey fields. We're based in Tulsa, but we have satellite offices here in Denver, which is where I'm located. We have another office in Carlsbad and Midland, Texas, and then in northern Oklahoma. So we've got a few offices spread out where we work on a variety of different projects. And so I'm as I said, a project manager here where we oversee the collection of potentially a lot of telecom jobs here and some of our local government. And so my background is a little bit like Mike's. I've got almost 20 years experience in the field. I used to work in local government in the GIS department, and then I moved over to DDSI about 5 years ago. And we use a variety of different tools essentially to get our field data collection in order to get our deliverables, which mostly for us are plats, where we have a group of signed surveyors where we produce exhibits, plats, and draft and design products. So I'm happy to be here, and I just want to thank everybody for coming to our webinar today.
Great, thanks, Mike. Mike and Mike. Yeah, great to have these guys here. They have a lot of field experience. I offer a little bit of that too. But first, so I'd like to move along, and here's sort of the agenda I want to cover today. I started doing this in the last couple of years, is including a glossary, because it, you know, being in this business, you end up throwing out a lot of acronyms, and a lot of times if you don't prep the audience, it doesn't make a lot of sense, or it can be confusing. So I'll have a short glossary, then move into high accuracy GNSS technology. I'm kind of going to give you a short update about what's changing. One of my themes in presentations I give at conferences is that GNSS technology is changing today more than it has in the last 15 years, and you might even be able to say 20 years. It's changing a lot right now. And you know, even though GPS has been around a long time, and a lot of you have been using GPS for 20 or 30 years, like these folks here, it's changing a ton now, and it's really fun being in this business at this point. And then we talk a bit about professional laser rangefinders. Moving on to the software, the Esri software integration, which really brings all this together, right? It's, you know, what's hardware without software? I mean, I remember back when I first booted up my first computer back in college in the 80s, and the operating system booted up, and I didn't know anything about it, and I'm waiting for it to do something, you know. But there was just a C prompt, if you remember the old DOS interface, and it didn't do anything. I'm thinking, well, what good is this? And really, it's I learned later it's really all about the software, because with just the hardware, it doesn't do much for you. You got to have software to bring it together. Then we'll move on to stories from Mike and Mike. They've got some field experiences and some great screenshots to discuss, and then we'll wrap it up with Q&A. So on to the glossary. So you'll hear me talk about GNSS and both Mike and Mike probably, but I still interchange GPS sometimes, just out of habit. And I tried endless years to convince GPS World Magazine to change their title to GNSS World, but they never did, I guess SEO or whatever. But really the sort of the generic term for GPS these days is GNSS, and because GPS is a brand name, that's the US system. There's other systems out there now, and so the overall acronym for all those systems is GNSS, and I'll talk specifically about those systems here shortly. RTK is real-time kinematic. That's a technique used with GNSS receivers to achieve 1 to 2 centimeter real-time accuracy. GIS is obviously geographic information systems, basically computer mapping with a database in the background. When we say collector, that's Esri's data collection software. That's collector for ArcGIS. It runs on iOS, Android, Windows. ArcGIS Online is a web mapping GIS that collector feeds data into. So that's Esri's product also. TruePulse, or LTI, LaserTech's handheld laser rangefinder lineup. TrueAngle is an angle encoder. Okay, so it's almost a little bit like a total station, but it really gives you accurate angles. So when you combine TruePulse, which is a laser range finding device, gives you distance and inclination, you combine that with the TrueAngle, which gives you accurate azimuth, then you get a 3D, a centimeter accurate 3D solution. And then lastly, we have the Aero EOS GNSS receivers, which are the GNSS part of this whole equation here. Okay. So really briefly, what is high accuracy GNSS? And I've used this slide a lot in many presentations over the years, and still the number one question I get from people when I present is, how accurate is GNSS? And that's sort of a loaded question, because there's lots of different types out there. You have a GNSS chip in your smartphone, and people say, well, hey, how accurate is my smartphone GNSS? And well, it's really variable. A lot of it is driven by the quality of the antenna used in the smartphones, and really the smartphone manufacturers don't care about accuracy that much, and so they allocate very little cost and design for the GNSS antenna, so that really affects the accuracy. It's, 'cause if you've got a bad antenna, I don't care how good your GNSS receiver is. It's like having it's like having bicycle tires on an Indy race car, right? You can have a 1,000 horsepower engine, but if you only got bicycle tires where the rubber hits the road, you're not going to get very good performance. So that's sort of the same analogy I use for smartphones and GNSS. So the accuracy is sometimes it's like a broken clock. It's right twice a day. It's all and high accuracy is all about consistency, right? And so I've seen smartphones be accurate down to half a meter, and I've seen them be as bad as 20 meters. Okay, so it just it depends. So I say up to 10 meters. And then you moved into sort of the Garmin handheld series. That's sort of in the 2 to 5 or 3 to 5 meter sort of range. And again, that's a couple $100 for one of those. Then you get into the entry level professional, sort of 1 to 3 meter range. That's sort of the Bad Elves of the world out there. For $600, $700, somewhere around there. Where the cost jump is when you go to sub-meter professional. When you try to consistently get under a meter with the receiver, you're not going to get it with a consumer receiver. You're going to get it with a professional receiver. And so you're looking at a price tag of sort of that $1,500 to $2,000 range. Then you get into sub-foot. And again, this is all sort of 95% confidence, right? So consistency is what it's all about with accuracy. And you're going to get into sort of the $5,000 range for a sub-foot receiver, and then centimeter you're in the $6,000, $7,000, $8,000 range. and I know we're talking thousands of dollars, but I tell you what, when I first started out in GPS in the 90s, even a 3 to 5 meter receiver was $10,000 or more. And even 10 years ago, a centimeter receiver was $20,000 or $30,000. So prices are coming down. They will continue to come down over time. And I think it's safe to say that eventually you'll see centimeter accuracy in your phone, whether that's 5 years out or 7 years out or 10 years out. I can't tell you, but eventually that's where it's going to go. Sort of the driver now is what the smartphone companies decide to do, because the technology's out there actually to do it. It's just a matter of if they want to implement it or not. So this next slide is talking about this whole GNSS is the new GPS, right? So GNSS is the overall term. So GPS is a brand name. GLONASS, the Russian system, is a brand name. Galileo is the European brand name, and Beidou is the Chinese brand name. But so each one of these four have their own constellations. And if you have a receiver that's capable of tracking all four of these, you really get a ton of satellites. I can remember back in the 90s or even 15 years ago when I was mapping a lot of golf courses, I learned really quick how many irrigation designers put sprinkler heads underneath trees. So I'd end up sitting out in the middle of a fairway with a laser rangefinder shooting trees from there. But it really would have helped back then, because it was just GPS for me back then, at least my receiver. But so I was tracking 5 to 6 to 7 to 8 satellites at a time, depending on the time of the day. But now if I turn on a receiver that's capable of tracking all four constellations, I can get 30 satellites in view. And right now GPS is fully populated. So there's 31 satellites in view. The Russian system GLONASS is fully populated. That's 24 satellites in view. Galileo and Beidou are still launching satellites. They're about 2/3 populated right now. But even then, today I'll go out and turn on a receiver, and if I'm tracking all four of these, I'll get more than 30 satellites in use actually. So it's really making a big difference in the high accuracy world, because when you have that many satellites, high accuracy is really satellite hungry. So the more satellites you have, the more places you can work with high accuracy. And this slide here just gives you an example this is a particular day. I think it was just a couple of days ago when I built this slide. So this is from 8 a.m. to 8 p.m. during the day, and this shows you the number of satellites in view for the different systems. And so you look at GPS, it's somewhere between sort of 7 to 10 satellites in view during the day. The red layer is GLONASS. That adds another 6 or 7 satellites. Galileo is blue, adds another 6 or 7. Beidou adds another 6 or 7. By the time you add it up, you see sort of midday, it's 35 satellites nearly, right? And this is with a 10-degree elevation mask.
Eric, I remember when I started using GPS in the early 2000s, I'd have to plan my field